Welcome to Nature Physics. Today we are going to discuss whether the universe is perfect or not. We use the word perfect in our language in everyday life. But does that resonate with our universe? To take a full grasp of the subject, we need to analyze it from a specific point of view. Besides, there are many ways to analyze this phenomenon, many of which can be in terms of energy. In depth, every single thing revolves around energy, even the laws which govern our universe, all the way from the Big Bang to black holes, from quarks to quantum mechanics, and from the search for planets to the search for life in the universe. Without further ado, let's dive into what perfection actually means. The interpretation of perfection as having all the required or desirable elements, qualities, or characteristics, possibly to be in the best version it can be. Examples of perfection in our daily lives are getting a 100% recommendation rating, a water pipe without any leakage, perpetual machines, and more. Back to the analysis of energy. Imagine a static universe whose energy is in place. For that universe to be perfect, the energy content of that universe must be distributed uniformly across all of its existing regions. To elucidate it even more, imagine a universe with just 5 separate galaxies that are not moving relative to one another. In order for that universe to be perfect, the energy content in each galaxy must be equal. Else the concept of perfection will be completely abandoned. For the concept of perfection to hold, the energy in each individual galaxy must be equal. So that was the first case. A quick recap on the first case. This universe was static, not changing, and the energy content was uniformly distributed. Thus, the first case was identified as perfect. The second case is a universe that is not static, in fact, is moving and changing. Since the matter in that universe is moving, the energy content will be different and fluctuating at every point in space. To illustrate this phenomenon, imagine 2 regions of space where there is more matter in one region than the other. Since we are speaking of a non-static universe, imagine that one galaxy from region 1 is about to undergo a collision course with the matter in region 2. According to the theory of relativity, E equals mc squared, which means that for any given mass there is energy. Thus, when the galaxy from region 1 collides with region 2, some energy from that galaxy will be transferred to region 2. By now, as you can see, this ends up with a remarkable result. Meanwhile, region 2 gained energy while region 1 lost energy. This then goes on to prove that the energy in that universe is not uniform and not perfect yet. But what could be done to make this universe perfect in terms of its energy content? The answer is simple. Simply, the universe must increase or decrease the energy content in some regions to account for the fact that as the energy increases or decreases in some regions, it needs to modify the energy such that it satisfies a perfect universe. We have just discussed 2 cases that allow for a perfect universe. Nevertheless, the reality of the situation is that our universe does not blend with the 2 presented cases. Our universe is similar to the second case in terms of it being non-static, but it does not blend with the notion of modifying the energy or a perfectly uniformly energy distributed universe. Our universe is not static, always moving, always changing, and always fluctuating. In fact, our universe obeys the first law of thermodynamics, which is the law of conservation of energy. It clearly states that energy cannot be created nor destroyed, but can change its form from one to another. For example, potential energy to kinetic energy, electrical energy to thermal energy to mechanical energy, and more. In the final thought, we have led with the conviction that our universe is not perfect, accounting for all laws that were set at the early stages of the universe since the Big Bang. Therefore, the notion of a static universe or a non-static universe whose modification of the energy content is possible would violate the law of conservation of energy and ultimately further laws. Thank you for watching this video. Please subscribe and share this video for future content. Until now, see you next time.